Hello, welcome to this capsule about Python for beginner scientists by Daniel Côté and Gabriel Genet. For whom is this video? Well, if you have heard of programming, if you have heard about Python, and if you are a scientist and you want to know more, then this capsule and this video is for you. So why do we program? We program for many different reasons, and you probably have your own reasons. But essentially, we program because we want to manipulate numbers, for example, to extract the calcium activity from movies. We may want to compute quantities. Let's say we have a statistical test and we may want to perform hypothesis testing. So for this, we would do that with a computer program. We may want to automate a repetitive task. We may want, for instance, to control a lab device or to write a macro for Fiji. So we may have different reasons, but in the end, we choose a programming language and we tackle our task. So why would we want to use Python? There are several good reasons, and I'll list a few here, but in every programming task, we'd like to have a language, a programming language that is with which it is very easy to express the problem that I have and obtain the answer that I want. So we want a language that is close to the problem to be solved. So writing your code is fast. An example would be if you want to do statistical tests, it's highly likely that R is the best language for you because it is specifically designed for that. If you want to program image analysis, then you could use the macro language of ImageJ or Fiji because it is made for that. Python is very good for a bunch of things, and we'll see that in this capsule and in the workshop on Thursday. But sometimes we also want reasonable performance. So we want something that is close to the machine or close to the computer so that running the code is fast. And Python is a very good compromise between the two. It's fairly easy to write code for a wide variety of programming problems. And at the same time, it is very efficient at running that code. So in the end, it becomes a language of choice for scientists. And it's especially important that there are, similar to MATLAB and other languages, there are a lot of modules that can be installed fairly easily to expand the capabilities of the language. Let's start with a simple program called the Hello World program. So we're going to write a small program that you will run on your computer to confirm that you have a functional Python installation on your computer. So we can import external modules, NumPy for instance, for computation, or OS for information about the operating system. We can define variables with this syntax. We can print things to screen. In this case, we're writing hello with the argument 0 being the name. We can write the numerical values with a certain format, and we can look up the name of the operating system we're using by calling functions from OS, or the operating system module. Like other languages, the Python language has for loops where we can iterate the variable I through 4 values, 0, 1, 2, 3, a range of 4. And then we can print the value of that variable and check that if that variable divides by 2 without a remainder, and if it's not 0, then that number is even. You notice that the range 4 actually starts at 0. It's not 1, 2, 3, 4, but really 0, 1, 2, 3. So if it is 0, we write that it starts at 0. And otherwise, if it's not 0 or an even number, it is an odd number. So there are a lot of things in this small script. We have external modules. We have variables. We have print statements. A statement is a single line of code with a format. We can use Unicode characters. We can use the character pi, for instance. We can use math functions, basic math functions from the language or from the external module NumPy. We can get information about the operating system or external information. We have for loops. We have various if statements. And you notice that the code is indented when it's inside a loop for clarity, but also because the language requires it. All right, so the building blocks. We have several building blocks, and we have variables of type floating point numbers, integers, and string. Python has tuples, which is a group of a few things. List is similar to an array, and a dictionary is a list that you can access with you can name the items. Finally, we have external functions like any other languages. All right, so let's get started. We'd like to get started. So first thing to do, let's install Python. So there is a small video that I prepared to install Python with Anaconda, which if you do not already have Python on your machine, then watching this video is the best option. Bon. So now that you've learned how to install Python, let's find a text editor that we can use to write our own Python code. So any text editor will do. And I personally like Sublime Text that is free on all platforms. You could even use Notepad if you don't tell me. But another fairly good option is PyCharm. That is free for academia, but you will need to apply for a license. You would need to do that at least 24 hours before the workshop if you want to have it ready. But assuming that you now have your text editor, now comes the time to run the code or write the code. So you can take this code and paste it into Sublime Text or in your text editor, and you could save it as Capsule 1. So if you do that, you will end up with your code in the appropriate document that you then save in a folder that you remember. I saved it onto my desktop. So if we go to in a terminal or in the Anaconda prompt, we can call Python capsule1.py and it will run our code. All right, so a few things to notice. If you made it this far, you have a working Python installation on your computer. There is no good reason to use Python 2.7 anymore. Notice the import module statement. There are many different modules, but there are standard Python modules that come with anyone installing Python on their computer. OS, sys, time, struct, math, random, CSV, etc. But there are also other modules that are very common that are not standard with Python, but they are fairly common that they get installed by many different Python installers, such as Anaconda. So for instance, NumPy and SciPy are very useful in academia, and that's why Anaconda will install them. But there are thousands of modules on a website called pypy.org that is the common method to distribute your modules. So for instance, I already mentioned NumPy and SciPy to manipulate numbers or with more advanced scientific algorithms, but there's also Pillow, called PIL for the Python image library to manipulate images. Matplotlib will allow you to make graphs, a very wide variety of graphs. CSV can allow you to read text, comma separated variable files or text files. Panda will do that with even more different time formats. Unit test, PyUSB, PySerial, various modules that are available with a simple pip install module name command. And my own group, DCC Lab, has a ray tracing module, a hardware library module, and a Monte Carlo tissue optic module. But this is just a glimpse of the many different modules you can get. And anyway, the way to install them is pip install module name or pip install module name -- upgrade or -- user to install it just for yourself or for everyone on your machine. So we have just set up our programming environment in Python on our machine, and we have looked at the basic structure of a program, which we have run. We have run a very small program that prints a few things to screen to confirm that everything was working. So we have a second capsule by Gabriel that will discuss more things in detail before you come to the workshop on Thursday. Thank you.